Have you ever wondered which metal would work the best in the shower to hold your shampoo, conditioner, and soap without corroding? Well, I have, because the soap holder in our bathroom is rusting and it's kind of gross. The first person documented to have discovered corrosion was Pliny, a great Roman philosopher. He wrote extensively of spoiled iron. He first discovered it because the Roman Empire, of which he was a part, used iron for weapons and other useful things. Many others, including Robert Boyle, Sir Humphrey Davy, and Michael Faraday, also contributed to our current knowledge of corrosion. Nowadays, after much experimentation, there are a number of ways to control corrosion. Making a choice on which corrosion control to use depends on safety requirements, economics, and a number of technical considerations. Protective coatings, the most common method of corrosion controls, can be metallic or they can be applied as a liquid paint. First, to conduct my experiment, I needed 5 2-inch by 2-inch pieces of each metal, which the metals were aluminum, mild steel, and stainless steel. Then I took 12 butter containers and filled them each about a third full with water. I stuck the pieces of metal in buckets and took one of each metal and put them in different spots. I had one group in my room, a group consisting of mild steel, stainless steel, and aluminum, each in separate buckets. I also had one group in our laundry room on top of our washer, which affected the temperature, one group on top of one of our cupboards, and one group on our back deck, which half the time was frozen. My hypothesis was that the mild steel would corrode the quickest. I came up with this hypothesis because, well, I've never seen stainless steel corrode before, and I just didn't think aluminum would rust very easily. I left these groups in their spots for about 2 months and checked on them on average every 3 days. The mild steel corroded the most, then the aluminum, and the stainless steel did not rust at all, though the water had a yellowish tint to it. The best metal for wet atmospheres is stainless steel, and I also learned that temperature affects corrosion to a great extent. For my graphs over here, I had to calculate the numbers that metals ended up being on a scale of 1 to 10. The stainless steel was not corroded at all, so they were all zeros. That's just these lines down here. And the aluminum outside was a 0. That's this line. And then the aluminum in my room ended up being a 3.5, and both the laundry room aluminum and the cupboard group aluminum were a 3 on my scale. The mild steel outside was a 2, partly because it was frozen. The cupboard group mild steel was a 6, and the mild steel in my room turned out to be a 7.5, and the laundry room mild steel ended up being an 8. Overall, my hypothesis was proved to be true. As you can see over here, the mild steel turned out to be pretty nasty. The aluminum has a white powder to it. There's some in the bottom of the bags here. And the stainless steel looks exactly like it did when I started the experiment. So my conclusion is that stainless steel would work the best to hold shampoo, conditioner, and soap.